Well, hello and welcome YouTube. Mr. Robinson back here with yet another brand new exciting video, all math-based of course, and as always, it is an honor and a privilege to be serving you here today, as it is every day here in my virtual classroom. Okay, step on inside, and this is a big meat and potatoes situation in Integrated Math 2, Big Ideas Math Textbook, section 2.6. 2.6, unfactoring ax squared plus bx plus c. Now note the difference between 2.6 has ax squared plus bx plus c, and 2.5 just has x squared plus bx plus c, where a is some coefficient that is not necessarily 1. Or maybe you can get a common factor and turn it into 1, but it doesn't begin that way. It can be a negative 1, or it could be a 10, or it could be a 2 or something like that, but we're going to be working on factoring these. Now if you just came off of section 2.5, hopefully that factoring made a little bit of sense and you got pretty good at it, if not pretty fast and pretty efficient. This stuff here is not quite as fast unless you get really good at it. And there's some strategies I hope to speak on in the way of how I work this. Now, I've done this kind of material before in terms of factoring, not in the Big Ideas Math 2 playlist. No, not necessarily there, but on my YouTube channel somewhere. If you find things on factoring polynomials of any sort, I have that. In fact, I'm going to link in the description section down below a video where I think I called it Factoring Factory. It's something that I did last year where I had like 300 problems that I factored or something like that. And they're not all of this variety. There's some that you won't have known how to do leading up to just 2.6. I think 2.7 and 2.8 cover a nice big bit of those, but outside of that, there's some others that you still couldn't do where you had to use something called the rational root theorem that's only covered in IM3. The point is, I have a video that's like 200 something, 300 something problems that I factor. And I don't know how long it takes me to do. I think less than 2 hours or something like that. But the point is, doing that many in that little time is you can do it and you can be that efficient with it if you know what you're doing. And you'll just watch me breeze through them as if it's my own thought process. So if you want to watch some of that, you can go ahead. I'm going to see what the book does on this. You can see where every so often I'm going to say what the book talks about I kind of use, but some other ways I have to spin it in my own way. So we'll see what they talk about for this factoring stuff. Let's go ahead and give it a look. We are going to factor ax squared plus bx plus c. Once again, that means that a is a non-1 value. Although, if there's a GCF that can turn it into 1, great. We'll do it just like the other stuff. And then use factoring to solve real-life problems. It seems like that's part of this stuff that we do a lot. Okay, factoring ax squared plus bx plus c. In section 2.5, you factored polynomials of the form ax squared plus bx plus c, where a is 1. That's what I mentioned. To factor polynomials where a is not 1, first look for the GCF. Okay, I love that they say this. This is the thing. GCF, greatest common factor. Every time that you do factoring, you are always seeking greatest common factor first, which includes leading negatives, a negative leading coefficient. If that's the only thing to factor out, you do so. But any extra x's, any extra factors of 2, anything like that, you factor out the GCF first. Besides asking why, I'm just going to go and say, well, the main reason why I'm going to say is it might turn your a into a 1, which makes things a lot easier to begin with. But the second reason, basically, why is when you factor, you have to factor completely anyway. So if you don't find a GCF in the very beginning, you're going to have to in the end, but it's a lot easier to work with smaller numbers. I'm just going to say it right now. You're going to notice it if I can't get one that's factored out and the numbers are bigger. Not necessarily bigger, but composite. And what I mean by that is there are more factors other than that number itself in 1. Like 3 can only factor into 3 and 1. But 8 can factor into 8 and 1 and 4 and 2. 12 can factor into 12 and 1. 6 and 2, and 4 and 3. When you get more factors of something like that in this kind of problem, it takes a lot longer. But if you can factor that 12 out, or factor 6 out of the 12 or something like that, it's really going to help. I should keep moving on. But it's really important. I'm going to keep stressing it. Every time you factor out GCFs. Period. Point blank, end of story. And then you factor further if possible. So we'll see if they can factor more than that. So in the first example, you see 5x squared plus 15x plus 10, and they're asking you to factor. Now, 5 is a GCF of all 3 of these terms. That's what they're showing you right here. So if you factor out the 5 to begin with, now you're left with a quadratic that says x squared plus 3x plus 2. The 5 remains on the outside or factored out with this thing, but inside you still have something more you can factor. What two numbers multiply to 2 and add to 3? Those are 1 and 2. So 5 times x plus 1 times x plus 2 is the factorization of 5x squared plus 15x plus 10. That's an example of what I'm showing by saying that factoring out the 5 first really helps this thing, because when that's a 1, it makes it a lot easier to answer this question here. So they did, and that's what happened. So these two, I'll factor these two for you if you'd like. This is no GCF, but this is 4x and x. I'm going to use my process. 4x plus 3 times x plus 1. If you go and distribute that out, I'm not going to tell you why yet. I'm going to do more of these later. I promise you. And this is going to be 3x and x, and this is minus 2 and minus 1 right there. So these factor into this. There was no GCF, but hopefully you can start to get somewhere near this speed that I just did, and that's what I'm hoping for. It's not as it's not as easy as what we did before. Now, they solve them for us. I thought they were saying these are ones that you try. I'm so sorry. I didn't even notice that. Okay, let's go into their process. I'll just say that I did them. There is no GCF here. There's no greatest common factor. So you need to consider the possible factors of A and C. A being 4 and C being 3. The factors of 4 are 4 and 1 and 2 and 2. And you notice this right here. They say 1 and 4 and 2 and 2. Same idea. The factors of 3 are 1 and 3 only. But what we have to do is look at all the possibilities of what factors here can lend it so that when we FOIL, when we do the outside times the inside and add things up, that we actually end up getting 13x in the middle. Now I need you to listen to this part carefully. This is important. Beforehand, we would say what two numbers multiply to this and add to this. Like as in what two numbers multiply to 3 and add to 13. Now there's no possible set for that. But the reason we asked that before, when you look at a problem like this one before, what two numbers multiplied and 2 add to 3? That's because when you did FOIL, x multiplied with 2 and got 2x. X multiplied with 1 and got 1x. It was just 2x plus 1x because these x's only had 1's in front of them. Basically, x times 2, 2 was the coefficient. X times 1, 1 was the coefficient. The numbers that you saw here were the coefficients of your linear terms. They added together. Now that we're dealing with an a value that's not necessarily 1, when you do foiling, such as x times 3 and 4x times 1, things like that, you notice this 4 is going to manipulate this number. 3 plus 1 may be 4, but I'm not looking at what 3 plus 1 is. I'm looking at what 3 plus 4 is. Why did I just say 3 plus 4? Because this becomes 3x plus 4x. This 4 is about to change this number drastically. 3x plus 4x is 7x, which is not 13, by the way. But I'm not looking for two numbers that multiply to 3 and add to 13. I'm looking for two numbers that multiply to 3, and when they work with the numbers that multiply to make 4, when you FOIL it out, they add to 13. So we're looking at the middle term. I like how they say this. I'm just going to say this up front. I love that they are using kind of a mental guess and check. There are other versions, and you're going to have a teacher who might not say this. You'll have another teacher that uses this form of some diamond method thing, which I think I brought up the other day, where you multiply A and C, where we do, what's 4 times 3? What's 4 times 3? Okay, that's 12, and you find two numbers that multiply to 12 and add to 13. Not that there's anything wrong with this, but it's not a guess and check that's going to get you doing it as fast as I just did above. Now, I imagine this video can go as long as it has to when it comes to me talking about this. So far, we're 8 minutes in, 8 plus, and I'm still on kind of one of the first examples here. But it's that lead-in that you kind of hear the thought process from me. I'll get an answer in my head before I even give it to you because I want to talk about process and strategy, and then maybe you can get to where I was at. But anyway, we tried a combination where 1x added with 1 and 4x added with 3. Remember, we checked factors of 4, 1 and 4. We checked factors of 3, 1 and 3. And we tried them to see if they together would add to 13 when you did the foiling process. X times 4x is 4x squared. 1 times 3 is 3. I'm good on those two. We're looking at the middle term now. This one didn't work. Let's try the next one. 1 and 4 and 3 and 1. Mr. Robinson, those are the same numbers. What's the difference? The order in which you write them. Now x plus 3 is here and 4x plus 1 is here. And this matters now. If your numbers are different, 4 and 1 are different, 3 and 1 are different. It matters because when you do the FOIL process, sure you get 4x squared here, sure you get 3 here. But the middle term is x times 1, which is 1x, plus 4x times 3, which is 12x. And 1x plus 12x is 13x. So this ends up working as your answer. The guess and check process of this, the nice thing is once you get to that part, you're at your answer. This is your answer. I wrote it differently, and I'll always write it with the bigger leading coefficient first. That's just the way that I go about it. They didn't seem to. But that's what you get. 4x has to be with 1, and x has to be with 3, so that when you FOIL things out, the outside plus the inside add to 13x. Just to show a little bit more, let's try what 2 and 2 would have given you. Factors of 4, 2 times 2, with 1 times 3. This time the 1 and 3 don't matter where you put them, because if I put a 3 here and a 1 here, when I FOIL, I'm still doing 2 times 1 and 2 times 3. Whereas here I'm doing 2 times 3 and 2 times 1. They still add to, or multiply to 6 and 2. 6x plus 2x is 8x, which is not 13x. You're trying to get to 13x, and it seems like it was the middle one that worked out. So your answer there is 4x plus 1 times x plus 3. Let's check the next one here. 3x minus 1 times x minus 2. Did I get that one correct? So here, once again, no greatest common factor. So we're going to test factors of 3 and factors of 2. And you can tell why I was so stingy on talking about why composite numbers versus prime numbers is such a big deal. Factors of 3 are just 1 and 3. Factors of 2 are just 1 and 2. All we got to do is try a number switch and see which order they're supposed to go into. Okay. So let's see which one works. When you pair up x, oh, and by the way, this was a, where is it? Oh, where's the problem? This was a positive product and a negative sum. When it's a positive product, the problem becomes a little bit easier. You'll know that either both numbers will be negative or both numbers will be positive. The negative sum meant both numbers would have been negative. So when you see these 2's, factors of 2, negative 1 times negative 2, negative 2 times negative 1. Okay, x minus 1 paired with 3x minus 2. You get negative 2x minus 3x. What I'm doing, once again, is multiplying these. Those are the cases of FOIL that make the middle term. Negative 2 minus 3 is negative 5. That's not the negative 7 we needed. What we need to do is negative 1 times, minus 6. Negative 2 times 3 is negative 6x. X times negative 1 is negative 1x. And negative 1 minus 6 is negative 7. We get that right there. So this is what it factors to. So my thought process is essentially that if you saw how I wrote it out, I wrote 3x and x. Why did I do that? Because I knew that 3 times 1 was 3 and x times x was x squared. I knew automatically this had to lock in if this was factorable. I'm curious to see if we get problems that are not factorable. I imagine they won't have that for us, but I'm prepared for it. Then I had factors of 2. I had one of two options. Either, and this is how they did it, either negative 2 and negative 1 here, where, remember, negative 2 times negative 1 is positive 2. So I'm all set with 3x squared, I'm all set with 2. I need to figure out negative 7. So how do I do it? I try 3x times negative 1. I do this in my head. Negative 3x minus 2x. That's negative 5x. No go. The 3 didn't multiply by something large enough. So let's switch the 1 and 2. Let's switch the 1 and 2. So now this becomes negative 6x minus 1x. That's negative 7x, and that worked out. So in my head, I'm already saying 3 needs to multiply with the number to kind of make it bigger, and I need to use the 2. That's good. There's a strategy involved, and there's a lot more than just that, but that's where I'm going to kind of get into with it. So I'm going to keep moving forward. They're going to ask us to factor 2x squared minus 5x minus 7. Once again, there's no GCF. So I'm going to look at factors of 2 and factors of negative 7. Now this one's a little bit different because, and I'm looking at you. I'm not looking at the screen right now. I'm just going to say this. I'm talking to you. I'll do this without looking at it. So the factors of 7, one needs to be positive, one needs to be negative. The factors of 2, both will be positive. So what are your factors of 2? 2 and 1. Period. I'm going to keep this as, without looking at the, I'm going to kind of like right over here. 2x and x. I hope that looks good. Now factors of 7. 7 and 1. So either the 7 goes on the left. Hopefully I'm looking at the right spot because I'm looking at you. Hopefully the 7 goes here and the 1 goes here, or the 1 goes here and the 7 goes here. Now, one's going to be positive, one's going to be negative. This one's going to be a little bit different than what we got to talk about last time. I'm just going to look at what I wrote. Plus, minus. Okay. I'm going to put a plus here and a minus here. I don't know if it's going to be correct. The good news is we need to add to what number? Negative 5. If I have the wrong signs, I'm just going to flip them. If I get a positive 5 result, I'm just going to flip these signs. Now, 7 and 1 are my factor tests. Let's do this together. 2 times 7 would be 14. That's going to make something that I don't think it's going to get me to 5 quite yet. That's too large. I want to try 2 times 1 instead. 2 times 1, did I put a negative? 2 times negative 1 is negative 2. Now, 7 is going to multiply with 1. 7 times 1 is 7, and 7 minus 2 is 5. I want negative 5, so I'm going to do is switch the signs. The answer should be 2x minus 7 times x plus 1. I'm going to write that. 2x minus 7 times x plus 1. Okay. This is what I was saying again. This is 2x squared. That's negative 7. This is 2x minus 7x. That's negative 5x. So let's see their approach. They have 4 possibilities. I was mentioning them. I don't. I technically would only test two of them. Excuse me. I technically would only test. Yeah, this is fine. I technically would only test two of them because I know that if I got a positive 5x, I would just switch the signs. It looks like the first thing they tested worked, and that can happen. That totally happens a lot. And they write theirs the other way. Notice that I have the x plus 1. They have 2x minus 7. So again, when you FOIL it, you get the negative 5x. It works out. Notice once again how your things work out. We only test one positive, one negative in these cases. And notice how there's a negative 5x and a positive 5x and a positive 13x and a negative 13x. Whichever sign things you have, if they're opposite, you just switch them. Okay. Factoring x squared plus bx plus c1a is negative. First things first, there may be no GCF as far as numbers go, but there's a negative leading coefficient. You factor that negative out. They're saying it right now. Factor negative 1 from each term. Negative 4x squared minus 8x plus 5. I'm going to factor the negative out, and I get positive 4x squared plus 8x minus 5. Beyond anything else, besides saying trust me that it works, negative 1 is considered a GCF. When they say factor, they mean factor completely, and that means negative 1 is among the things to factor. What do they say here? When I use negative factor, then factor 2. Yes, it's besides the fact it makes things easier. Just trust me, it does. Just trust me, it does. Now, I also happen to know that this is going to be some form of 2x and 2x. Trust me, I haven't looked down below. This has to do with even numbers versus odd numbers. I'll tell you about it more in a bit. So I know it has to do with that. I also know that one's positive, one's negative, and I don't have to switch these things really at all because one's 2x plus, one's 2x minus. It's got to be some form of 5 and 1. It's either this one or the other. Negative 2 plus 10 is 8, and it will be this. With the negative on the outside, that'll be the answer. So, what are their tests? They tested 1 and 4. I'm going to show you how I don't need to bother testing 1 and 4, and here's how. Look at their results of their answers. They got negative 1, 19, 1, and negative 19. What's the result of all those answers? They are odd numbers. How come they got odd numbers? Because they had the result of an odd number plus an even number, an odd number plus an even number, an odd number plus an even number, and an odd number plus an even number. Because odd times odd is odd, and even times odd is even. What happens when you do odd plus even? You get odd. You know what this number was? Even. How do you get an even? Either from an odd plus an odd, which is impossible because 4 is an even number. That means one of the factors has to be even. Or an even plus an even, just like this. Even plus even plus even. Now, I only had one. I literally could have tested only one thing. I wouldn't have lucked out. I did luck out, but I only could have tested one thing, and I could have known what my answer was. If I tested this one first, 2x plus 1 times 2x minus 5, I would have gotten negative 10 plus 2. Negative 10 plus 2 is negative 8. Not the answer, but it's the opposite of the answer. So what do? Switch the signs. You get 8. 10 minus 2. 8. Only evens can come out from having two evens from there, and that's what would have gotten it. Okay. So there's some down here. I'm just going to show with regard to speed. Normally I wouldn't do this kind of thing, but it's a trusting process thing. On number 1, I have a GCF of 8. If I factor that 8 out, then I have this, and this is where I can answer with this being a 1, what two numbers multiply to 6 and add to negative 7, and it's those two guys right there. So that's number 1. Number 2, let's see, I can write these above. No GCF, and there are some composites. This one's going to take a moment for me to try. I'm going to try some things. We'll try 7x times 2x. That can give me 14x squared, and they're all positive, so I know I can add. Let's try some form of 5 would be too large. 7 times 5 is 35. Let's try 7 times 3 and 2 times 5. So 21 plus 10, that's 31. I'll let you know, I was lucky. I could have done 14 and 1, and I could have done 15 and 1 in some combination. I just lucked out on that one, on the first guess. But there are only so many guesses before I find out what works and what doesn't. 2x squared minus 7x plus 5. I need to have 2x times x here. Both need to be negative for a positive product negative sum. And I'm doing these before the actual problem set itself. So you're getting a little bit more. You're just getting a little bit more. I kind of like doing these things here. It's either 5 and 1 or 1 and 5. If I put a 5 here, I get negative 10. Too big. I got to put a 1 and a 5. Negative 2 minus 5 is negative 7. That works out. Impressed it? Here we go. This is before the problem set. But you know what? Because I'm doing it before the problem set, I'm going to say when the problem set starts, I'm going to be going this fast. Essentially. Because I want to talk strategy right now and see how we can work it out. No GCF, so I'm going to go 3x times x. Negative 14, first of all, positive product, negative sum, minus and minus. 8 has different factors. There's 8 times 1 and 4 times 4. But because 3 and 1 are both odds, the only way to get 14 an even number, 4 times 2. The only way to get even numbers is from both even factors of 8. It's either this answer or it's this answer. And I haven't tried to calculate anything yet. I'm just telling you, it's either one of these. I'm not going to bother with 8 and 1 or 1 and 8. So let's try this. Negative 6 minus 4 is negative 10. That's not it. Negative 12 minus 2 is negative 14. That's it. So it's going to be that guy. Now, I do a lot of this in my head. I'll write out those first parts, and the number testing after that, I'll do in my head. So I'll do it with this one right here. I'll talk about it, but I'll do it here. So this is either 4x times x or 2x times 2x, but it won't be 2x times 2x because 19 is an odd number. The 2's here would make it even. So 4x times x, positive product, negative sum. This is where I might write plus and minus, but generally in my head I don't. I'll just kind of switch things around. 5 and 1 or 5 and 1. 5's got to go here to make 20 plus or minus 1. Negative 20, plus 1. Negative 20 plus 1 is negative 19. Number 6. This is one where I can't play the even odd thing to its strengths outside of knowing that 12. Hold on. I'm going to write this down below. Outside of knowing that 12 can't be 6 times 2, but it couldn't be anyway. I'll show you why in a second. I'm going to try 3x and 2x. I have no idea if I'm going to be right or not. I got to test some things. It's trial and error. Now 12. Here's the thing. 12 is 12 and 1, 3 and 4, and 6 and 2. It can't be 2 and 6 for a couple reasons. Number 1, I have an odd result. I can't have 2 even terms. Number 2, this didn't have a GCF. Here's a new strategy, and I'm going to talk about it here. This didn't have a GCF. So if I had 6 and 2, look at this. 2 and 6 would have a GCF, but this problem shouldn't. If I had 2 and 6. 2's would have GCF, 3 and 6 would have GCF, so that wouldn't work. So part of my strategy, trying 3 and 4 or 12 and 1, and I'm going to likely try 3 and 4 first and see it. If I try in 3 and 4, it can't be here because they would have GCFs that we shouldn't otherwise have. So it would have to be 4 and 3. I don't know if this is right yet, or I have no idea. One's a plus, one's a minus. Let's see if this works. Negative 9 plus 8 is negative 1. I needed positive 1, so I just got to switch these. This will be the minus. This will be the plus. This is 9 minus 8, and that worked out. Listen, I lucked out again. Sometimes I like to work the middle factors instead of the big factors because generally big factors tend to leave me some extremes in numbers if the numbers are bigger, and this isn't one of them here. So I'll just keep talking strategy in your ear. You're going to have to slow me down because, man, I work quick fast on these. Number 7, I can factor a negative out of here, and I have 2y squared plus 5y plus 3. Negative 1 was the GCF. Now, as I factor that, I have a 2y times y. These are all positives. 3 and 1, 3 and 1. The 3 going here would be too big. Let's put the 1 and 3. That's 2 plus 3, which is 5. So this is the answer. Notice the negative is still out there. Number 8, I got a negative. I'm going to go a little faster than, oh, hold on a second. I'm missing something. I need to write the term before. Never go straight into the answer there. Negative 5m squared minus 6m plus 1. Okay, I'm going to go fast this time because they're all prime numbers. Minus. Listen, there's only one possibility here. Factors of 1 are 1 and 1. Both have to be negative because of the sum. This is the only possibility. Negative 5 minus 1 is negative 6. So I had nothing more to say. And the last one, let's keep going down. Negative 3x squared minus x plus 2. I can factor a negative out of that one. I have 3x squared plus x minus 2. And keeping the negative factored out of there, 3x and x, all prime numbers, 2 and 1, 1 positive, 1 negative. Let's try 1 and 2. That looks like that'll get negative 3 plus 2, which is negative 1. So switch that, and here we'll get, boom, 3 minus 2, which is positive 1. Boom, just like that. So these are just examples, not even the problem set. It's the first time that I kind of wanted to do something like this and say it out loud. You'll probably hear that thing in my factoring factory video as well. All right, solving real life problems. Let's take a look at this one. Let's hold on. How much time? It's got 25 minutes in just the lecture. The length of a rectangular game reserve is 1 mile longer than twice the width. Ooh, we get to actually set up kind of things. The length, which way is length? I guess here. Wait, is this a photo? I guess, wait, the photo's not the reserve. But, okay, well, here, let's pretend like, I was going to say let's pretend like it was. Now, let's just do this. The length is 1 mile longer than twice the width. So the length we can express in a different way. 1 mile longer than twice the width. So instead of writing length there, we can write 2w plus 1. Boom. So also it's rectangular, so opposite sides are congruent. The area is 55 square miles. What is the width of the reserve? So we're going to solve for w given this. We're going to multiply length times width, 2w plus 1 times w right here and get 55. If you then distribute this, you get 2w squared plus w is 55. Subtract it over. Now notice they also did the same thing here that they didn't do before. We got to solve for w. It's a quadratic by nature. We got to set it equal to 0, but you got to distribute it out to find something that's now factorable. Now they're going to play with factoring here. I'm going to ignore that. We're going to look at it for ourselves. We got 2w times w, something equals 0. 55, there's either 55 and 1 or 5 and 11. I'm going to go with the 5 and 11 crowd just because I'm more comfortable with it and it seems like something I want to try more. So 5 and 11, something like that. We get 10 minus 11, which is negative 1. Let's swap that. Let's get, and so, you know, I say I luck out. Literally, I haven't tested it before, but it's those numbers. I'm not going to try 55 and 1 if they add to 1 first. It'll be noticeable. If this number's huge, like in the 50s or hundreds, then you can tell 55 and 1 would happen. So it's going to be this, 2w plus 11 times w minus 5. Now, when it equals 0, I'll let them do the rest. When 2w plus 11 times w minus 5 equals 0, we use zero product property. Remember that? So w minus 5 equals 0, or w equals 5, or 2w plus 11 equals 0, or w equals negative 11 over 2. Now, this is one of those cases where you can't have negative width. We only have to have positive width, so this answer doesn't apply. Only this does. The width is 5 miles. They didn't ask about the length, but the length would have been 11 miles, because 5 times 11. So width is 5 miles, and there's the answer. Okay, I'm going to just move on to some of the practice set now. Let's look at the 1 and 2. What is the greatest common factor of the terms of 3y squared minus 21y plus 36? Well, that would be 3. The GCF is 3. It's the largest value that can divide out of all three of these. And we're just good there. Notice that they didn't have us factor out any variables. There was no GCF of y as well. They could have one. They're not playing with it here, apparently. We'll see if they do. Compare factoring 6x squared minus x minus 2 with factoring x squared minus x minus 2. Okay, this is a good one to talk about because assuming they're both factorable in that way, this one's significantly easier. This one is what two numbers multiply to negative 2 and add to negative 1. That is negative 2 and positive 1. Minus 2 plus 1 gets you that. But this doesn't just become 6x minus 2 times x plus 1. No, you need numbers that multiply to negative 2, but when combined with your factors of 6, can then add to 1 in that, negative 1 in that way because of the foiling process. So it's either 6x and x with negative 2 and 1 and things going to that, or 3x and 2x. And I have no idea which. Generally, I like to try these smaller ones first. I think I still want to. Now I know what it is just by thinking about it. But if I try here, I can do like plus and minus, and I couldn't try 2 here because no GCF, so I could try 1 and 2. That's negative 12 plus 1, which is negative 11. No good. And same thing here. I'm not going to try the 2 here, but the 1. But the 2, let's try there. That's negative 3 plus 4, which is positive 1. We got to swap that to get negative 1. Negative 2 and positive 1. 3 minus 4 is negative 1. So it's going to be that. Takes a lot more to do for this kind of problem. Not quite the same here. Now, this was just coincidence that 3 and 2 came with a minus 2 and plus 1. It was just coincidence that it looked almost the same as that otherwise. But takes a lot more. Takes a lot more. Okay, so that was numbers 1 and 2. I don't know how much that was vocab or anything. I think it just seemed like all the other problems that we have here. Okay, I'm going to go ahead and start the actual problem set with you guys here. Let's go ahead and take a look at what's going on. We're going to factor the following polynomials. Now, I'll just say, if you're jumping in to this part for the first time, I spent 30 minutes doing other examples, talking about other things and strategies. I'm going to bring them up here. But I value my time. So while I talk about them, please understand that I brought them up in the lecture. That's what the lecture's for. Some of it was kind of fast. This is having you practice good factoring strategies so you can be just as whip fast as I am in these scenarios. 3x squared plus 3x plus minus 6. Hopefully you hear me in every problem seek a greatest common factor before I move forward. This one has a greatest common factor of 3. You're left with x squared plus x minus 2. Now, wasn't the last problem we just did have this just the number 2 above? I think so. So this becomes 3 times x. What two numbers multiply to negative 2 and add to 1? That's a positive 2 and a negative 1, just like that. Now, the 3 stays factored on the outside. That's part of the GCF talk. That's actually what we get from that. Okay, number 4. 8v squared plus 8v minus 48. I can imagine these first 6 problems, numbers 3 through 8, are all about getting the GCF of this value right here before you move forward. 8 can factor out. You get v squared plus v minus 6. Now we're trying to find what two numbers multiply to negative 6 and add to 1. And that would be 3 and negative 2. Now, I'm going fast on that part because that's 2.5. This is 2.5. The GCF is 2.6. I would argue they should have done these 6 problems. If all 6 are like this, I would argue they should have done these 6 problems in 2.5. I get it that it's an ax squared where a is not 1, but when you can factor that a out and you just came off of GCFs before in 2.4, that it essentially is that. When I teach it to my kiddos, I'm going to probably encourage them to look at these here as well. Okay. So this next set, again, 4 is a GCF of all these. You're left with k squared plus 7k plus 12. 3 times 4 and 3 plus 4 would give you that result. So k plus 4 and k plus 3. 4 times 3 is 12. 4 plus 3 is 7. Notice how you don't lose what's here. This factoring into this means these have to be equivalent. So keep that in mind when you're doing them. Number 6. We have 6y squared minus 24y plus 18. Oops. 6 is a GCF of all these terms. 4y plus 3. 2 negatives minus minus. This will be negative 3 and negative 1 in some sort of way. Those are the only factors of 3. Minus 1 minus 3. That'll work out for me. Negative 3 times negative 1 and all that. Number 7. 7b squared minus 63b plus 140. Okay, there are more factors of 140 than normal, but we need to get 63 out of it, so I think we can come up with it. Oh, wait, I take it back. There's a GCF. Duh. I was thinking, like, just b squared. All right, let's have fun. Factor the 7 out. It's going to become a lot smaller. Minus 9b plus 20. All right, much better. Now, negative 5 and negative 4 fit the bill there. b minus 5 times b minus 4. Love it. This is kind of like the factoring factory thing, if you want to take a look at that, of course. GCFs first, and then the like. 9r squared minus 36r minus 45. See, these ones are fun when you know how to do them and what you're doing, and it's good number sense. All about good number sense here. Multiplies to negative 5 and adds to negative 4, excuse me. 1 positive, 1 negative, the negative 1 being bigger. Negative 5 and positive 1. Sometimes I speak faster than I can write it. So r plus 1. Okay, those are the first 6 where there was a GCF that led you to a basic factoring. Now we go to 9 to 16 where I imagine that, I don't know if there's going to be GCF or not, but I imagine that this is going to be the actual when a is a is not 1 factoring, which means you have to find something different for two numbers that multiply in that sort of way. If you saw my lecture, you know what I'm talking about. I'm going to keep talking strategy as much as possible. I'm going to talk in your head all day. So 3h squared plus 11h plus 6. No GCF this time, so we're going to have to live off this. 3h squared comes from some 3h times h. 6 either comes from 6 times 1 or 2 times 3. Now, which order you put these is important. Plus and plus, all positive products and sums. I could try... So here's the thing. Here are going to be my possibilities. I will slow down a little bit this first time. If I do 6 and 1, I'm going to put them right here. If I'm going to do 2 and 3, I'm going to put them right here. There's no way I'm putting the 6 or the 3 right here. And that's because 3 would be a GCF of both 6 and 3. And if there was no GCF here, there will be no GCF here. So the only possibility is either this or this. Which one? Let's try 3. 3 times 6, let's try this. 3 times 6 is 18, already too big. I need to add to 11. This is already too big. It's not going backwards. Let's try this. 3 times 3 is 9, plus 2 times 1 is 11. It becomes that one. So let's erase the previous one above, and that ends up being the answer. So 3 and 2. I only tested one thing, whereas other people would have tested up to 4 things. Now, my test would have been a lot faster than this. It would have been in my head, in and out. That's the thing that you need to work on in the FOIL part. To clarify, 3 times 3 in FOIL is 9. 2 times 1 is 2. 9h plus 2h is 11h. We already have these give us 3h squared, and these already give us 6. Okay, number 10. We have 8m squared plus 30m plus 7. Time for some of my strategies to come into play. I know this will be some form of 4m times 2m. You might say, why not 8m times 1m? Because 4 and 2 are even numbers. And with 7 having only, by the way, no GCF. With 7 having only odd factors in it, the only possibility of getting an even number here is from some even plus even. I need to get to 30, which is pretty big. I imagine I need to multiply the 7 with the 4. 7 times 4 is 28. 2 times 1 is 2. 28 plus 2 is 30. That's the answer. Again, there's some trial and error that I can talk about and bring about. Let me just talk about the 8m and 1m. No matter what I do, putting in some form of 7 and 1, it's always going to be some even plus odd. Even if I switch 7 and 1, it's still going to be an even plus odd. 30 is an even number. I'm going to go straight to that. Number 11, 6x squared minus 5x plus 1. The good news is about the 1 is not only is a positive product, so I know that this is going to be, whoopsie, let me do that again. Not only do I know that it's going to be a, with a negative sum, that it's going to be a negative times a negative, but, so I already know this is going to be minus 1, but 1's also it's not a prime number, but there's only one set of factors, 1 and 1. 6 can either be 3 and 2 or 6 and 1. If you did 6 and 1, 6x, that'd be negative 6 minus 1, which is negative 7. I need to get negative 5, so let's try negative 3 and 3 and 2. Negative 3 minus 2 is negative 5. Now, I haven't answered this part yet. If you tried everything, and the book actually tries everything more than they should, but if you try everything under the sun and it still doesn't factor, or there's no possibility, that means it's not factorable, or it can't factor further, basically. Because you might have GCFs, and then maybe that's all you can do, just GCFs. That might be the extent of it. Number 12, 10w squared minus 31w plus 15. By the way, I also want to mention this. I'm using the same strategy that the book is, only I'm talking about it out loud. I'm giving you more number-based strategies. Number sense is very important for this. We want to get the answer correct, but we also want to be efficient. My video will not suit everybody. Right now, I'm about 40 minutes in before I'm saying that, and I probably should have warned and prefaced that. Your teacher will probably teach differently than I do. They won't be faster than I will be. But if they teach differently than I do, then there's that. You might have to stick with what your teacher goes by. I'm going by what the book goes by. If the teacher goes by the book, then these strategies that I'm talking about are exactly what they're talking about, and then some. I'm giving less things than the book is as far as trial and error. I'm limiting it by putting no GCFs together, by the odd and even talk, the negative and positive talk, switch the signs after, things like that. So they're all there. And I don't know if I wrote this book, I don't know how I would talk about those things. It's kind of, it's a lot to say. But this isn't for everybody. And if this hasn't been for you yet, I mean, I would do one of two things. I'd either keep pushing and keep listening and keep trying to understand, or I'd back out. It's one thing where it might not work for you, but we're really working toward best strategies possible. And that's what I'm going for. Your goal is to get these ones right and in an efficient manner. Anyway, no GCF here. This one will take a couple more things to try. I do know that there are negatives here, but because 10 and 15 are both composite numbers, I have a couple things to test. I can try 5w with 2w, and I can try 10w with 1w. I don't know which one works yet. They're both odds and evens, all that kind of jazz. I'm not sure, but I do know among these it's going to be that. Now, when I try 5 and 3, I will not try the 5 with 5 here. I will try 3 here. Same thing. I will not try the 5 here. I will try the 3 here. It's one of these two answers if it's the answer. Which one? Negative 25 minus 6 is negative 31. This is the answer. What would have this given me? Negative 50. Too big. And that's another strategy. Too big for negative 31. There's no way I'm going to actually get that value. And this one's it. Number 13. By the way, I don't know if they mentioned that whole GCF, you can't put 5 in there, because I don't know if they did test those or not. I have no idea. I don't remember. 3n squared plus 5n minus 2. You know what? Let me check that. Give me 1 second. I want to try something. I want to see something. I'm going to go back. I want to see what they did on some of these here. Or did they not give problems that didn't have the GCF possibility? Okay, they didn't give problems that had the GCF. So they throw you into the mix with them by saying, we're not going to give you the examples so we talk about it and stuff. We want to just, that, right? That. It's the book being the book. I mean, that's, books do that kind of thing. All right, 3n squared plus 5n minus 2. Good news is both 3 and 2 are primes. That means it's either 2 and 1 or 1 and 2. Those are just the only two options. Plus, minus, maybe. Whoops. Plus, minus, maybe. I need to get to 5. So 3 times 2 is a good bet. I'm going to try this. I get negative 6 plus 1. That's negative 5. So I just got to swap these signs. Now, one of these days, I'm not going to write that part out. I'm just going to say that I know it's already a difference. I actually would just be doing 6 minus 1 in my head. Even if I needed negative 5, I would just know to switch the signs personally. So there it is. So there's not much work you're going to see from me on these problems. I am working it out the way that my head should talk about them, right? And I might be erasing some parts. 4z squared plus 4z minus 3 on number 14. I know this has to be 4z and 1z, not 2z and 2z. Oh, excuse me. I know this has to be 2z and 2z. I was looking at the 3. I know this has to be 2z and 2z, not 4z and 1z, because I need an even coefficient from odd factors here. So I need to do some form of even plus even. So it's either that or switching the signs. Negative 2 plus 6 is 4, and that's the answer. It was either negative 3 and 1 or negative 1 and 3. The two z's don't have to change your order because they're the same value. Number 15. We have 8g squared minus 10g minus 12. Now this has a GCF, but the GCF is only 2. It's not a boo-hiss. It's much better to reduce these, make them a little bit smaller. In fact, this gets me down to the idea that this is now an odd number, so I know that this has to be 4g and 1g. That's really nice. So trust me, this really, really helps me. It takes away my thought from 8 having to be 4 to all these kinds of things to this. It's really helpful. Now, 6 is either 2 and 3 or 6 and 1. I don't know which one. Let me do this in my head this time. Like, I'll try. Here, let me write this. 3 or 1 have to go here, and 2 or 6 have to go here because of being a GCF with 4. I can't have it. So let's try 1 positive, 1 negative. 8 minus 3 is 5, so it's got to be negative 8 plus 3. That means this has to be a minus 2 plus 3. So those are the ones that I tried, and that one worked out. And I know some people are really probably confused in what I'm talking about. Let's work this one backwards. I got you the answer. Let's just work backwards and see what I'm getting. If I FOIL this thing back out, what happens? 4g times g is 4g squared. 4g times negative 2 is negative 8g. 3 times g is 3g. 3 times negative 2 is negative 6. Remember, the factors that I'm choosing are factors that get me these numbers. Those are the first things that I try. By the way, there's a 2 on the outside. Those are the first things that I try. That's what I'm testing out of. I don't need to test them again. I know that's what I'm getting. In foiling, there's outside and inside. And my goal is to get ones that when I do 4 times negative 2 plus 3 times g, that I'm getting negative 5 as a result of that. And that's what that is. So this becomes 2 times 4g squared minus 5g minus 6. When distributing the 2, you get 8g squared minus 10g minus 12, which gets you back to where that was. But this is the answer here. That's the answer there. All right, number 16. I said I wouldn't slow down and look at it. Number 16. 18v squared. And remember, imagine my factoring factory video, the 300 some odd problems. I'd probably be about halfway done compared to this video. Whatever, I don't know how long my video was. I should look back at it. by 18v squared minus 15v minus 18. I think I had to spend 2 different days on it, though, because I had to go to, I had to coach a softball practice or something. There's a GCF of 3 here, so I can get it down to 6v squared minus 5v minus 6. 6 has 6 and 1 and 3 and 2. I don't know which combination this one is, but I do know that the 3 can't ever go with the 6 or the 3, and the 6 can't go with the 3 or the 2, 3 or a 2 or anything like that. So with the 3 factored out, let's try 6 and 1. Let's just kind of play with this one a little bit. So if it's like this, 1 positive, 1 negative, no idea which. Oh, you know what? It can't be 6v because I can't put a 3 or a 2 in here with 6. So I know it can't be 6v. It has to be some combination of 3 and 2 or 2 and 3. So cool. So I know this has to be some form of 3 and 2. And if it does, the 2 and 3 have to be on the other side. There's only one test I'm going to do, and there are only 2 possibilities. Here's one possibility, and the other is switching the signs. So is it this? Negative 9 plus 4? Yep, that's negative 5. So there you go. I couldn't even... Remember, I said I couldn't test 6 with either 3 or 2, but I also couldn't test it with... Oh, you know what could have been possible? I take it back. This could have been possible. 6v and v with 1 and 6. I'm sorry. This could have been a test. But this would have given you what? Negative 36 plus 1. Negative 36 is way too big. So only 2 real tests that I would have actually had, and that's one of them. Okay, factor the polynomial. We're going to these. Now, if you notice, all of these have a linking chain. They all have a common trend here, which is a negative leading term. Now, we're in standard form. Keep in mind, you want to be in standard form when it comes to factoring, but when your leading term is negative, factor it out. Point blank, period, end of story. Even if there's no other number that can factor out, such as this. I'm factoring out a negative 1. Here's what's left inside. The negative 1 will stay on the outside as I continue to factor this. So 3t times t, both are negative here with a positive product negative sum. 6 is either 6 and 1 or 2 and 3. If we do it like this, it can't go with, these can't go with the 3, so they're on the opposite. Let's try 6. Negative 18 plus 1, that's not it. So let's try 3 and 2. Negative 9 minus 2. Excuse me, I said negative 16. I said negative 18 plus 1. I meant negative 18 minus 1. Negative 9 minus 2 is negative 11. So it seems to be that one. With the negative factored on the outside, that's the result. Number 18. Negative 7v squared minus 25v minus 12. Okay, factor the negative out of here. We get 7v and, excuse me, I keep doing that. I know that's not how I'd write it for myself. 7v squared plus 25v plus 12. Now, with that negative factored out, I got 7v times some v here. Everything's a plus inside, so plus and plus. 12 has 12 and 1, 6 and 2, 4 and 3. It won't be 6 and 2 with this even thing here. If it's 12 and 1, I ain't going to put the 12 with 7 because that'll give me a huge number. I could try 12 and 1 like that. I'll get 7 plus 12, which is 19. It's close, but it's not it. So I'm going to try the 4 and 3, and I don't know which order. If I put a 4 here, 7 times 4 is 28. It overshoots it, so I'm going to try the 3. 7 times 3 is 21, plus 4 times v is 4. 21 plus 4 is 25. There it is. So that's, once again, I probably get there faster, like by myself without talking to you about it, but that's where I'm going with it in my head. You can erase parts, you can write parts more and more, you know, the book does it. You probably don't have to make a whole table. Again, unless your teacher talks about it, because they want to make sure you get the answer. You don't stop short, you've exhausted all possibilities. But I'm avoiding possibilities I don't have to do. That's the difference. I'm making sure I don't do possibilities I don't have to do. That's the strategy. Anyway, factoring out a negative like you would. So here, once again, this will be 4c times c, not 2c times 2c, because the odd number 19. And 5 and 1 has only possibilities of 1 and 5, or 5 and 1 like that. 1 positive, 1 negative. I wonder which. I got to get to negative 19, which is pretty big. I want to multiply my 4 with 5 if I can. So let's try this. Negative 20 plus 1, that's negative 19. There it is. Again, I didn't luck into it. I did not luck into it. There is an educated guessing thing with what we do. I'm not doing a full trial when I say educated guess. What I mean is that I'm trying enough things to understand sizes and signs and evens and odds and common factors. And I keep talking about this because this is where you can get to if you practice. And not just 20 problems. Hundreds. At least dozens. GCF of negative 1. I get 8h squared plus 13h minus 6. I'm going to be dealing with 8h and 1h given the odd result here, not 4h and 2h. 1 positive, 1 negative. 6 is either 3 and 2 or 6 and 1. The 2 or the 6 will not go with 8. They'll go over here. So let's try these sets. Let's try 3 and 2. That's negative 16 plus 3 is negative 13. I need positive 13, so I'm going to switch these signs. Boom. The 6 would have given me 48. I could have told you right then it would have been too big. So that's not going to work. But this will. 16 minus 3 is 13. 21. I have negative 15w squared minus w plus 28. Negative 1 GCF. And we have positive 15w squared plus 1 minus, plus w. Plus 1w minus 28. See, when I speak to you guys, I mess up more because I'm saying plus 1. Okay. Now, 28 has several factors, but 14 and 2 is one of them. 2 even numbers. Ain't going to get that with a 1 here. So listen, I don't know the answer right now. I'm not going to try and work it out in my head. I'm going to try 5 and 3 here. 28, we can have 28 and 1, 7 and 4, 14 and 2. I think that's it. I'm not going to try the 28 necessarily unless it works with 15 and 1. It could, but I don't think so. I'm going to try the 4 and the 7. Those are ones that can generally get you more toward the smaller numbers, like a 1 here. So 1 positive, 1 negative. Let me do it without writing the positive and negative. Just understand that we're going to have a difference with these numbers, like 35 minus 12, which, by the way, is not 1. So let me swap that. Let's try 7 and 4. So that's 20 minus 21, which is negative 1. So that means, so which sign? I need a negative 20 plus 21, right? So negative 20 plus 21. So that's where you don't need to write the signs first if you have to erase them after. If all you had left to go with was pen, you can do a lot of things in your head if you're able to, and that's it. Number 22, we have kind of strange numbers here. 22 d squared. So let's see. Negative 22 d squared plus 29d minus 9. I have a GCF of negative 1 to begin with. 22d squared minus 29d plus 9. 22. 11 and 2 or 22 and 1. I'm actually fascinated by the 22 and 1. It could be that, but I'm going to begin with 11 and 2. I think they tend to. I'll tell you what. It's possible because I think this was true by factoring factory thing because the problems were randomly generated. I didn't make the worksheet. I would never make that many problems, especially because I got to make them factorable. Never. But what I wanted to say is that they crippled the numbers to something at some point, some amount. I don't know if this book is going to give us numbers where 22 is a factor. They might only go... Have you seen anything higher than 12 as a factor? Have you even seen 12 as a factor? They might only go as high as 12. I don't know. But I'm going to go for smaller numbers first if I can. I think they're just better to deal with. Now, 9 is 9 and 1 or 3 and 3. The bottom line is, I know these are both minuses, but I don't know which one's which here. Let's try 3 and 3, see where we get to. That's negative 33 minus 6. That's too big. If I put a 9 here, it would also be too big. So let's try 1 and 9, like that. That'll be negative 11 minus 18, and that is negative 29. So that did work out. Again, I imagine that 22 and 1 is just going to be it's just going to be too big. I just don't think, not too big as for our values, too big for the book. I don't think the book just gets factors that big, I think. All right, error analysis. I can imagine what one of the error analyses will be already. I'll tell you if it shows up. But I think it's the one where they say what two numbers multiply to this and add to this with totally ignoring what the first number is. So we'll see if that shows up. All right, describe and correct the error in factoring the polynomial. Well, I see that they screwed up the GCF. So if you see here on this problem set, 2x squared minus 2x minus 24, perfect attack on factoring the 2 out, but only the x squared got factored. This isn't a common thing that people make a mistake on, to my knowledge. The 2 and the 24 never factored a 2 out of there. And so as they continued, this is correct from here to here, but that's not the correct answer because from here to here is incorrect. So When factoring out the 2, which was correct to do, not only should you, it's a must you. Although they correctly identified 2 as a GCF, the GCF, 2 never factored out of the linear and constant terms. Now, let's see what happens when they do factor out and if they still get something that's factorable. I imagine they do. They ask us to correct the error. So we are going to go from 2x squared minus 2x minus 24. When you factor a 2 out of there, you get x squared minus 1x minus 12. Yes, that's factorable. This factors into x minus 4 times x plus 3. So you can see the different answer compared to the other one. They're not the same thing. And that's number 23. Number 24. 6x squared minus 7x minus 3. Okay, they didn't do the error that I was bringing up, but let's take a look at what they had here. Now, before I identify what their error is, let me bring up this once again, because I've talked about it, but I don't know if it's come to fruition. In fact, I'm going to write it on my page. So I'll write it in red to make sure you don't copy it down. 6x squared minus 7x minus 3 equals 3x minus 3 times 2x plus 1. If someone asked me, Mr. Robinson, is this the correct factorization? I would have immediately said no. Here's the reason. First of all, well, it's all within the same thing. If this was correctly gone about, it's not completely factored because there's a GCF of 3 in both of these. But the bigger thing is within that GCF. This has a GCF of 3. GCF of 3. And this does not. How can your factored set have a greatest common factor of 3, but your original one can't? That's not possible. That's why whenever I say that when I'm testing things, I'm like, I'm not going to put the 3 here. I'll put the 1 here and the 3 here, which this could be the answer. I have no idea. But I'll put the 1 here and 3 here because you can't put something to give it a GCF when it didn't have one to begin with. And if it did, you should have already factored it out. It should have factored out to begin with. So the real issue, besides the fact that it's not correct, is that they factored it with a GCF. They factored a quantity that contains a GCF when the original expression didn't have one. And if it did have one, you should have factored it out to begin with. They should have factored it out. I don't know if I've made enough of certain statements to convince you that GCFs are the first thing that you should always take care of, because maybe I didn't cover all the reasons other than composites, more factors is a lot harder and things like that. But among them, even if this was a correct factorization, it's still not complete because the GCF of 3. You don't want to wait till the end to try and find GCFs, because if you didn't find them in the beginning, you're unlikely to notice them at the... Oh, I didn't finish. You're unlikely to notice them at the end as well. Not only did I not finish, I didn't put that circle there. So let me just save this for the next page. So you're unlikely to notice later it because you didn't look from the beginning. I promise you that. You do need to factor them out, period. This doesn't have one. This doesn't have a GCF. Now, were they near correct? Well, let's factor it ourselves and see what we get. I do want to start with the 3x and 2x, just, because. Now, with the 3 and 1, again, I won't put the 3 here. I can't, so 3 and 1 would have to go here. 1 positive, 1 negative. Let's see if this is the right order. Negative 9 plus 2 is negative 7. This is the correct answer. I mean, I could have tried 6 and 1, but that's the correct answer. Now, what was different from their answer? They had minus 3 and plus 1, but in the wrong spots. See, when we FOIL, we don't multiply these two and multiply these two and add them together. No. So it's these two multiplied plus these two multiplied, and that ends up being it. Okay, that's 24. Let's look at 25 to 28, where we solve the equation. This is where you set it equal to 0, you factor, and you solve using this zero product property. So here we have 5x squared minus 5x minus 30 equals 0. There's a GCF of 5, which I wonderfully factor out. You have x squared minus x minus 6 equals 0. I think we factored with this before. That's minus 3 and plus 2. Now, the zero product property comes into play. This was something taught before in section 2.4. Please go back to that if you want to see more on it. If 5 times x minus 3 times x plus 2 equals 0, either 5 equals 0, which is impossible. You won't see me write that anymore. That doesn't work. There's no x's have any bearing on that. Or x minus 3 equals 0, so x equals 3 when you add 3 to both sides. Or x plus 2 equals 0, so x equals negative 2 when you subtract 2 from both sides. These are your answers that solve this equation. Plug 3 back into there, plug negative 2 back into there. You should get 0 out if you use correct math, correct order of operations, and the like. Number 26. We have 2k squared minus 5k minus 18 equals 0. It's in standard form. It's set equal to 0. There is no GCF, so you are looking to factor right now. 2k comes from, 2k squared comes from 2k times k. Negative 18 has several factors, 18 and 1, 9 and 2, 6 and 3, all of which are one odd, one even. I have multiple ones to test. If you want to try 18 and 1, don't dare try the 18 with the 2. That'll multiply too big. I think it's too big on this side. I'm going to ignore that. I'm going to try 9 and 2. 9 is still too big. 2 times 9 is 18. Let's try 9 on this side. By the way, 2 couldn't go. Oh, 18 couldn't go on this side with the 2. Neither could the 2. Neither can the 6. So let's try this one. This is negative 4 plus 9, which is positive 5. Let's switch those signs. That'll be like that. 4 minus 9 is negative 5. So if this times this equals 0, either 2k minus 9 equals 0. Or if k plus 2 equals 0, we know that one. K should be negative 2. But you got to be more careful on this one. We still have to add 9 and then divide by 2. We get 9 halves. And please leave it like that answer. Again, I taught this stuff before, so I'm going to go a lot faster on the zero product property portion. The goal of this is to get the factorization correct. All right, number 27, we have negative 12n squared minus 11n equals negative 15. Despite the fact that n's a common factor in both of these terms, or negative n if you will, if it's not set equal to 0, it doesn't matter. Now, I could add 15 to both sides, and I will. I'll show one version, you add 15 to both sides, but keep in mind, you do want to, and you really need to, I think you should, well, you have to, in factoring completely, you have to factor out a leading negative in this thing if your quadratic term is negative. So I would have to factor out the negative 1 before I'd move forward, and then you keep factoring inside of here. Contrastingly, however you put it, you can also add 12n squared and add 11n to both sides, so it's now 12n squared plus 11n minus 15 equals 0. I just went ahead and just put it on the left side of the equation because whatevs, I can. But look, it's the same thing now. You say, no, there's a negative on the outside. Remember, it's a negative 1. Negative 1 can't equal 0. This won't be a part of my zero product property. From here, I can just move on into there. Divide both sides by negative 1. I don't care what you do. The negative now has no bearing on it other than when I factored it out and got the signs how they should be. So let's keep moving forward with 11 being here. 12 and 15 are composite numbers. There's a little to work with, but they both have factors of 3 in them. So that means whenever I list this out, let's try 4 and 2. I'm not going to try 6 and 1 because of the even. Whoops. Let's try 4 and 3, I should say. 6 and 2 would be even sets. Now, when I try factors of 15, a plus and a minus, right? I'm not going to put 3 here or 15 here. I got to put 5 or 1 here. So let's try 5 and 3 and see how that looks. A lot of the mid numbers tend to work a lot. And this one does. This is negative 20 plus 3, which is negative 11. I need positive 20 minus 3. Again, you can call this lucking out. I've seen these before. Not this. Whoops, I'm not done. I've seen these kinds of problems before, so, you know, I know what they tend to work off of. If 4n minus 3 equals 0, then we add 3 and divide by 4. We get 4n equals 3 and n equals 3/4. If 3n plus 5 equals 0, we subtract 5 from both sides and then divide by 3. We get n is negative 5/3. Last one from this set, number 28, we have 14b squared minus 2 equals negative 3b. I'll keep that visible. 14b squared minus 2 equals negative 3b. Keeping my quadratic term positive, I'd like to add 3b to this side and get it in standard form. So this will be a plus 3b minus 2 equals 0. By the way, I try and model things and demonstrate them and all that stuff. A lot of people tend to lose the equals 0 at some point. Do not confuse equations from expressions. Originally we factored and we didn't solve anything. Now we're solving. This equals 0 needs to be here. For zero product property, you need it set equal to 0. So don't lose the equals 0 as you work. It needs to be rewritten exactly like that. It just does. Now, no GCF here. That means it's either 14 and 1 or 7 and 2. Guess which one I'm going to start with. But by the way, equals 0. So let's try 7 and 2. 2 and 1, the 2 would have to go here, not here, if this is going to work, because GCF stuff. Let's try a negative and plus, see how we get. We get negative 7 plus 4 is negative 3, so I'll go and swap these and get a positive 3 out, and I'm good to go. Not done. Not done. If 7b minus 2 equals 0, we add 2 and divide by 7, we'll get 2 sevenths. Or if 2b plus 1 equals 0, we subtract 1 and divide by 2, we get negative 1 half. Okay, that was just the first column. We still have 3 more columns to go, but significantly less problems because we only go to number, what does it say, 48? I'm more than halfway done, and hopefully after all this, it seems like it could go faster. I have no idea. I haven't done them yet. In 29 to 32, find the x coordinates of the points where the graph crosses the x-axis. Now, this reminds me of, I forget if it's 2.4 or 2.5. I'm going to say 2.5. It reminds me of 2.5 where you are, that crossing the x-axis is where y equals 0. So in the original problem where we have this equation of the entire parabola, which we graphed these kinds of things in chapter 3, we set y equal to 0, and then we solve. So it's just another way of them asking you to solve for x here. Those become the x-intercepts. So let's factor this guy, set equal to 0. 2x times x, 35 is a classic 5 times 7 case. Let's try one of them here, 5 and 7. Why not? This becomes negative 14 plus 5. That's not negative 3. Let's swap them. Oh, equals 0, by the way. This is, now let's try negative 10 plus 7. That's negative 3, so that works out. If 2x plus 7 equals 0, 2x would equal negative 7, so x is negative 7 halves. Yeah, hopefully you can hear out loud what I'm saying if I'm skipping certain steps. 2x plus 7 equaled 0. So now I subtract and divide. If x minus 5 equaled 0, x would equal 5. I do these parts in my head. I go straight from here to here, personally. You just got to know what you're doing and why you're doing it, right? Now, by the way, these are the x-intercepts. Does that look like those answers here? X equals 5? That looks like x equals 5. What's negative 7 halves? That's negative 3.5. Looks right. I'm going to go based off the answer to kind of verify that it works. And that's something about this problem that I like. You can kind of see your answer without the scale. Number 30. Looks like x equals negative 3 is going to be an answer. That's fantastic, but let's actually try and get to it. What's the other one? I don't know. Probably 1/4. We'll see what that is. Number 30. We have y equals 4x squared plus 11x minus 3. We're going to set y equal to 0 because that's where y equals 0 is the x-axis. That's where we find x-intercepts. When I factor this, 11 being an odd number means I'm going to only test 4x with 1x. 3 is 3 and 1, 1 and 3. Let's check things. 4 times 3 would give me a 12. That's going to get me close to 11. So let's try plus 3 minus 1. That's going to be 12 minus 1, which is 11. When I say let's try it, I mean I kind of already stumbled on it. So we're just kind of putting it in. So if 4x minus 1 equals 0, 4x equals 1, and x is 1/4. And if x plus 3 equals 0, then x is negative 3. So let's check those. We get negative 3. And remember, that is negative 3. That works. And I said a quarter, and it is a quarter. So that works out. It looked like it. Number 31. It's an upside down graph. That means it's negative. So negative leading term. We have y equals negative 7x squared minus 2x plus 5. I will set this equal to 0. Now, I have 2 ways of going about this. You saw me say it the other way before. We can either factor out the negative, or I can add 7x squared over. Take a look. I can do plus 7x squared on both sides. I can do plus 2x on both sides. And I can do minus 5 on both sides. And guess what? Now it's positive. It's not about what's on the outside factoring. It's about what values of x give us 0. And negative and positive 0 are both 0. It doesn't matter which way it works. That's not how we say it. You factor this into 7x times x, prime numbers. 5 is also a prime number, 5 and 1. If I put a 5 here, I'd get 35, too big. Let's try 1 here. 7 minus 5 would give me 2, so let's do that. Boom. If this one you know is x equals negative 1. Let's try this in our heads. 7x minus 5 equals 0. Add 5, you get 7x equals 5. Divide by 7, you get x equals positive 5/7. And there we go. Negative 1 and positive 5/7. It looks like it hits negative 1. 5/7 is a little bit less than 1. It looks like it hits that as well. And number 32, this time I will factor the negative out as it's another upside down graph. Let's take a look at that. We get y equals negative 3x squared plus 14x plus 5. Set this equal to 0. Factor the negative out of here. We get 3x squared. By the way, let me just say this really fast. In equations versus expressions, we can totally do this thing to both sides, right? In expressions, we can't. If I go back to one of the beginning problems, like one of these where they just said factor, blah, 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 I can't just ditch the negative and say, oh, add 3t squared. To what? It's an expression. These are equations. And furthermore, when they're set equal to 0, some special things kind of just happen. It's kind of nice. All right, so 3x squared now minus 14x minus 5 equals 0. So negative stays, listen, the negative stays on the outside, or you can divide everything by negative 1. I'm going to keep it on the outside. The point is, that's not the part that gets me a solution for x. It's inside. It's what's inside here that matters. The 3x times x to give me 3x squared, and some form of 5 and 1. Notice how 14 is a big number. I like to multiply 3 with 5 if possible. So 5 and 1 like that. I need 14 to be negative, so I'd like negative 15 plus 1, like that. So subtract 1, divide by 3, x would be negative 1/3, or add 5 to both sides, x would equal 5. Do those look like our intercepts? That looks like an x-intercept of 5, negative 1/3, I believe it, and there it is. Okay, now we're dealing with a lot of problems that are probably all the modeling, critical thinking, all that kind of stuff. So it could slow down. A couple word problems, real-life applications. Let's see what we got. How far have we gone? How long have we gone? An hour 12? Okay. Modeling with mathematics. The area in square feet of the school sign can be represented by 15x squared minus x minus 2. Write an expression that represents the length of the sign. Now, they give us the 3x plus 1. Maybe it's as a courtesy. This is only factorable in one way if it's factorable. So let's go and factor it together. You know I would have gone with a 5x and 3x to start with anyway. And 2 and 1, there's either 2, 1 or 1, 2. And let's see which one it is. I forget what the answer is, so I'm going to look back at this. Negative 10 plus 3 is negative 7. Even if I got positive 7 by swapping signs, that's not going to work. Let's go and switch that. So 1 and 2. Negative 5 plus 3 is, plus 6. Negative 5 plus 6 is positive 1. So I'm actually left with swapping these signs here. And I get that. That was actually more testing than I generally do, although I didn't try 15 and 1. So there's the factorization. So they gave us the 3x plus 1. I guess that's the width. So this is the length, which is 5x minus 2. And giving us 3x plus 1 is really helpful. If I did this knowing that, that means that if 3x plus 1 is one of them, then remember, you're thinking about 3x times what gives you 15x squared. That would have to be 5x, and 1 times what gives you negative 2. That would have to be negative 2, and you just double check and make sure that it foils out. We get, again, 5 minus 6, and that's negative 1. So giving you that's really helpful for the problem, but of course, us working on this is a good strategy. So here's the answer, 5x minus 2. That represents the length of the sign. That was part A. Part B. Describe 2 ways to find the area of the sign when x equals 3. Well, the manner is substituting 3 for x. So way number 1 is by substituting 3 for x into the original expression here. Sorry about that kind of thing. Which becomes 9 times 15 is 135 minus 3 minus 2 is negative 5, which is 130. Square feet. Or way number 2, you substitute 3 into the factorization. So 5 times 3 minus 2 times 3 times 3 plus 1, like that. Sorry for squeezing that in. Let's kind of move these. There we go. So 5 times 3 is 15. 15 minus 2 is 13. Times 3 plus 3 is 9. 3 times 3 is 9, plus 1 is 10. 13 times 10 is 130. So your two methods are plugging it into the original polynomial or the factored one. They don't mention that enough. We've had problems like that, way more than that, for this to be the first time that they've asked us that. I mean, they can ask it whenever they want. It's just that I've shown those different options so many times with you guys that I'm surprised the first time they bring it up. All right, the height h in feet above water of a cliff, the height h in feet above the water of a cliff diver is modeled by h equals this, where h is the time in seconds. What does the constant term represent? How long is the diver in the air? Okay. I have well, I don't know if it's great. I'll link it to a word problem set as well, although there are a lot more things that they talk about than just this. But I bring up, I was going to write h of t, which is normally what they do. I could bring up that word problem thing on quadratics if you'd like to see it, because it's these kinds of questions that have this. Now, the model of this, see, the problem with this is you probably don't know what graphs tend to look like in this scenario. Quadratics are parabolas, but when the leading term is negative, it becomes an upside down parabola. That's why leading term is so important when we talk about this stuff and the coefficient, whether it's negative or positive. Now, the 80 is at time 0, because when t is 0, you're at the the h-intercept. It's at this axis here. So when t is 0, you get 80. 80 represents where the height of the diver at time 0. That means 0 seconds, the height of the diver is here. What does the constant term represent? It's the height of the cliff. Here's where the diver begins. This is a diver, right? So here's where the diver begins, and they're 80 feet above the ground. So we're going to answer that part. They also ask, how long is the diver in the air? This is, like I said, an upside down parabola. A parabola that ideally would look like probably something like this, because the diver's got to jump, right? It jumps and comes back down, boom, like that. Hits the water, boom, hopefully survives. 80 feet is pretty big. Now, the time before 0 is irrelevant to the model. Generally, they like to work on that kind of stuff. So you're really only focused on what happens in the very beginning of this model right here. When the diver jumps, boom. Now, this doesn't mean that the diver goes outward. They could go pretty much straight up and down. This is just time moving on. But they are going to ask you how long the diver's in the air. So that's this other part right here. And that is, when is the height 0? The t-intercept, the x-axis, if you will. So, two questions here. The first one was, what does the constant term represent? The constant term, 80, represents a couple things. The height of the cliff. Geez, my stylus thing. I'm sorry about this. I can't put a T. There we go. Represents the height of the cliff, and therefore the starting position of the diver. The starting height of the diver. Now, I've mentioned these things before. I think the book has as well, so it's something that they kind of expect you to figure out through that without knowing the graph. I'm just giving you the graph as well. By the way, this is water. Boom, 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 boom. I hope they're diving into water. They don't say. Oh, above the water. Yes, they do. Negative 16t squared, I mentioned before. This is force of gravity. It has to do with this. The 8t is the initial velocity, if you will, upward velocity. This is in feet per second. So the diver's jumping up 8 feet per second. That's the initial velocity. So there's what the constant term represents. How long is the diver in the air? We still have to solve that part. So we have to find out kind of this t value right here. Now, there's a second t value that will exist that's negative. We're going to ignore that one. That's not the one that we're going to end up using. But we've got to set the height to 0. Negative 16t squared plus 8t plus 80 equals 0. Notice how this all crawled to a snail's pace. I can factor out a negative 8 from here, and I can get 2t squared minus 1t minus 10 equals 0. Listen, the negative 8 has nothing to do with this problem now. I'm solving for values of t where there's no t on the outside. If this times this equals 0, either negative 8 equals 0, which is impossible, so I can just divide both sides by negative 8 at this point. I could have from the beginning, but I really want to speak to factoring because in an expression you cannot divide, but here I can. So I'm now just left with 2t squared minus t minus 10 equals 0. Keep in mind, y equals 2t squared minus t minus 10 is way different than y equals this. Way different graphs, but you know how they're the same? They both cross h equals 0 at the same place. Where? Let's factor. 2t and t. It's either 10 and 1 or 5 and 2. Let's try 5 and 2, but the 2 would have to go over here. The 5 would have to go over here. Minus 2 and 5. Let's see. Negative 4 plus 5 is positive 1. I need negative 1, so let's swap that. Negative 5 plus 2. There it is. 4 minus 5 is negative 1. So if 2t minus 5 equals 0, we add 5 to both sides and we divide by 2 and we get 5 halves. Here, if we subtract 2, t plus 2 equals 0, we get t is negative 2. Now, negative 2 was the time that's to the left here that is irrelevant to the problem in the model. The diver is not ascending up to the cliff here. That's just this model. This part of the model doesn't count. So this part's going to be outright ignored. Now, 5 halves is the answer, but it's a word problem, which generally means our units should be applied a little bit better. So how long is the diver in the air? The diver is in the air. 5 divided by 2 is 2.5. Is in the air for 2.5 seconds before they meet their ultimate fate. That's where you go from a fraction to maybe a decimal answer, because it's more of, we don't say 5 halves seconds. You could say 2.5, but we generally kind of at that point use that. Okay, you can see this really went to a snail's pace since we hit number 29. Let's keep moving forward. Number 35. The Parthenon in Athens, Greece is an ancient structure that has a rectangular base. The length of the base of the Parthenon is 8 meters more than twice its width. The area of the base is about 2,170 square meters. Find the length and width of the base. So with this problem, we have Parthenon rectangular base here with some length, some width. Now, the area is 2,170 square meters. So length times width is going to be 2,170. The problem is we need to try and get one variable in this. They say the length of the base is 8 more than twice its width. Now, I'm not going to spend time talking about how you write those things out, but the order that I wrote it was really important. If it said 8 less, it would have to be minus 8, not 8 minus. So the length is that. So instead, we can substitute 2w plus 8 in for L. I'll put the w first just because that looks a little better. Length times width, or width times length, is 2,170. Okay, now we're going to try and solve this thing. Find the length and width of the base. So I'm going to distribute w and get 2w squared plus 8w equals 2,170. Subtract 2,170 from both sides to set it equal to 0. And then factor a 2 out or divide both sides by 2, however you want to put it. But we should get this. Oh, what is that? 1085? Honestly, I don't know factors 1085. I know I can divide by 5. This might be a second for me. But divide everything by 2 and you just get this part here. Now, the nice part about this is that we are... Well, you know what? This won't be necessarily too bad. My numbers have to be 4 apart. Because this is a 1w squared, I am just finding 2 numbers that multiply to this and add to that. And remember, they have a difference of 4. One of the numbers has to be 5. So the other number can end in a 9 or 1, 30 times 30 is 900. So it could be 31 times 35 or it could be 35 times 39. I'm going to venture a guess it's one of those two. And I'm going to guess it's 31 times 35 because 35 times 35 is 1,225, which is more. So I'm going to guess that this is me not having done this problem before, 35 and 31. Now, I still got to test this. I don't know. This is negative 31 plus 35. That's 4. That's fine. I don't know if 35 times 31 is it. You know how I'm going to test it? I'm going to be doing the difference of two squares thing we did before. 35 is 33 plus 2. 31 is 33 minus 2. And let's see what we get there for difference of two squares. That distributes to become 33 squared. Oh, I don't know 33 squared. 33 squared is a perfect square. Hey, I'm just having fun with the problem. I'm just going to do what I know. I don't have a calculator, and I just want to do this. This is my video. So this becomes 900, square the first term, double the product of these two, double 90, so 180, and then double 3 is 189. So that becomes 1089 just from 33 squared. So 33 squared is 1089 minus 2 squared, which is 4. 1089 minus 4 is 1085. Okay, so that's the factorization. Yay, we got there. So moving down the page of nothingness, we have w plus 35 times w minus 31 equals 0. So either w is negative 35, which doesn't work, no negatives, or w equals 31, which should work. So the width is 31, that's 31 meters. They asked to find the length as well. The length was 8 meters more than twice its width. So 8 meters more than twice its width. 2 times 31 is 62. 62 plus 8 is 70. You get 70 meters. So the length is 70. The width is 31 meters. Boom. No calculator. And more fun with difference of two squares and perfect square trinomials. Okay. I said this was slow to snail's pace. It definitely has. Number 36, modeling with mathematics. The length of a rectangular birthday party invitation is 1 inch less than twice its width. So the length is 1 inch less than, see, that's important. 1 inch less than, it's not 1 minus 2w. No. 1 less than twice its width. Not twice its width less than 1, right? Okay. The area is 15 square inches. Will the invitation fit in the envelope shown without being folded? Explain. Okay. So the length is that, and the W is W. So when I do width times length, I'm setting it equal to 15. Distribute the W, so 2W squared minus W equals 15. Subtract the 15 over, you get 2W squared minus W minus 15 equals 0. I feel like we had this to factor before. I don't remember, but I feel like we did. So 2W and W. Let's try 3 and 5. And that's, again, I don't think 15 and 1 are factors that I don't think the book's just going to do it. So you can just work with 3 and 5. 3 here, 5 here sounds good. So I want negative 6 plus 5. Negative 6 plus 5 gives me negative 1, so that works. So here you get W of negative 5 halves. Subtract 5 divided by 2. Here you'll get W of 3. So this width won't work. This width will. So that is 3 inches. Now the length is 1 less than twice the width. Length is 2 times 3 minus 1, which is 6 minus 1, which is 5 inches. So that area is 15. That seems to work, and blah, blah, blah. Does it fit within here? Yeah. This is a 3 and 5/8 by 5 and 1/8. This was a 3 by 5. You know what? As I was reading the problem, I was thinking, oh man, I got to multiply these and see if the area is blah, blah, blah. No, you just got to check and compare these things. So yes, it'll work without being folded. So yes is the answer to my question. Number 37, open-ended. Hey, remember when I said that was it critical thinking or whatever it was, looks like open-ended questions? This is now open-ended. So I wonder what the difference is between the two. I think it was where they said critical thinking or open-minded. I forget. Write a binomial whose terms have a GCF of 3x. All right. Well, one way to do this is to have the 3x starting off there and then write something inside like, I don't know, 6x minus 1. No, I want to do something. 6x minus 7. And then distribute. And now I'll have 18x squared minus 21x. What did this have to do with our stuff? That's it. They said write a binomial's terms have a GCF. Yeah, there it is. Okay. All right. That's it. Yeah, have a 3x factored out and distribute it in, and you have an answer. So there's mine. Number 38. Now, oh, by the way, nothing inside here, I think maybe this is a part of it. Nothing inside here can have a GCF. No GCF inside. So if I did 6x minus 10, that's no good because there would be a larger GCF within. I guess part of it is have everything GCF'd out, basically. Number 38, how do you see it? Without factoring, determine which of the graphs represents the function g of x equals this and which represents h of x equals this. Explain your reasoning. Okay. Without factoring, the process of factoring includes the whole positive product, positive sum, positive product, negative sum. Now you have to be careful on part of it as well, because the factorization, I'm not factoring, but I'm giving the idea of factorization. This factorization will have some sort of x minus this times x minus that. And this factorization here will have some sort of something plus this and something plus that. But what they're talking about for the graphs, these intercepts, remember when you set it equal to 0 and you solve, this is where your x's become positive. This gives you positive roots because you add the things over, and this one gives you negative roots because you subtract things over. So this is going to be g of x. Curve K is g of x. I'm explaining the reasoning to you. I'm going to write it here and value my time. K is g of x and L is h of x. And the reason, again, is because the intercepts are solved for after you factor, and the factors have different signs based on their sums. This is a positive sum, negative sum with positive product. Positive sum, negative sum. The factors with negatives in them will end up having positive roots. The one with positive all factors will have negative roots. I put 28. That was 38. Excuse me. Number 39. When is it not possible to factor this ax squared plus bx plus c where a doesn't equal 1? Give an example. When is it not possible to factor? There are a lot of times, but what kind of case are they talking about? I mean, I wonder what they're asking me to kind of use. Like, I want to give an example to teach what I'm talking about. I mean, this isn't factorable. There, that's not factorable. First of all, well, let's mention, hold on, before I even talk about that example. Number one, no GCF. No GCF, possible to not factor. So no GCF. Number two, I mean, it's just that whole head honcho thing. Why isn't this possible? Because I gotta get factors of 2 here, factors of 100, which could be 100 times 1, it could be 10 times 10. The point is 2 is gonna multiply with one of these plus x times 1. I need to add to 3. So basically, when in FOIL, I'm just gonna say when, because this is how I talk about it. When in FOIL, the O and I parts can't add or subtract or whatever to your B term from your F and L factors. Factors of 2 and factors of 100 are not going to get me something that can add to 3. Maybe there's a version, if this was a negative 3, that yeah, maybe there's a subtraction version of it, but that's the basic case there. So now they haven't given us a problem that was unfactorable, which is kind of interesting that they throw, oh, I'm sorry, and here's the example, 2x squared plus 3x plus 100. Example. There are a bunch we can give. Literally, there are more things that don't factor than things that do factor. They give us problems that are factorable, which they're being nice about. They've created the problems probably by testing the other way. But they haven't given us one that isn't factorable yet. And I'm not saying that they should. I'm saying that with this question in mind, it would have been nice if they had one, so we can kind of talk about, well, this is why it didn't work. We've exhausted every possibility and it didn't work. All right, your friend says that to solve the equation 5x squared plus x minus 4 equals 2, you should start by factoring the left side. Is your friend correct? Explain. Well, your friend's not correct because you should set it equal to 0 to solve using zero product property. Now, they're not asking us to factor and solve it, so I'm not going to do that. But I want to remember, do you guys remember in my last video I said that the friend argument one, I said they likely switch every time. Do you remember if the friend was correct the last time? I'm going to go and venture a guess and say, I bet they switch it every time. So if your friend's incorrect this time, let's go back and find that section 2.5 video where making an argument where your friend was, I bet your friend was correct that time. So your friend is incorrect here. So next time, I got to remember this. Your friend's not correct this time. I expect your friend to be correct next time. Your friend is not correct. The equation must be set equal to 0 if you want to solve by factoring. because the zero product, they hyphenate it, because the zero product property must be in use to solve that way. Period. There's no way around solving by factoring if you don't set it equal to 0. Period. Number 41. For what values of t can 2x squared plus tx plus 10 be written as a product of two binomials? Okay, this one's kind of interesting because with this one we get to, we don't have to test things per se. Now, well, I'll say a couple things, but we don't have to test things per se. We just give all the different possibilities that there are, which is nice. So they ask for the values of t, so we get to test them all. The one thing is we don't want to put any that has a GCF, because if it has a GCF, then it's 2 times something. That's not a product of two binomials. That's a product of a monomial times two binomials. So we have to make sure that t doesn't end up being even. And the way to make sure t doesn't end up being even is when we try 2x with x, we do not, by the way, t can be negative values. They don't say that it can't. But, so we'll put pluses and minuses. I'm going to write all these different sets for you guys. But we don't do factors of 10 where 10 or 2 show up here. They have to be on the other side because we can't have a GCF of 2. So we can do 10, which means this is 1. We can do 2, which means this is 5. And then we can do minus versions. With a plus 10 sum, that means that these, which I wouldn't have to write these out because I'm going to tell you what the values will be. This can be 1 and 10 and 2, 5 here, and then 2 here. Whoops, x minus 2 here. Now, they still asked us what values of t. I'm not done. These are the factors that would work out t. What does t come from? Outside plus inside. 20 plus 1. So 21. Here, 4 plus 5. 9. And you know what this is going to be? Negative 21 and negative 9. We couldn't have done ones with 10 here and 2 here because that would lead to even numbers, which would lead to a GCF of 2, which we're not allowed to have for this scenario. So these are the different values of t that are possible. Okay, number 42. Yeah, tiles. I don't know how to work with tiles, especially with negatives in these situations. I can copy and paste it over, but we'll see what they have. Well, I don't have to copy and paste. I'll write out their expressions. Use the algebra tiles to factor each polynomial modeled by the tiles. Show your work. So again, I'm going to represent the tiles. I think section 2.5 had these. Basically, the first one in part A, those first two are x squareds. They're positive. 2x squareds. Then there are 5 x's, and those are negative, so that's minus 3. So I'm going to factor that guy into 2x and x. I need to get a positive from here with 3. I can do 2 times 3, which is 6, minus 1, which is 5. Boom, there's the answer. Hopefully you've gotten pretty fast at it now, or you're not watching this part of the video anymore because your teacher didn't assign you these questions. So part B, we have a 3x squared, and then a minus 2x there, and then a minus 1. So 3x and x, remember 1 can only come from negative 1 and positive 1. I want to make the 2 negative, so I want the negative 1 here to get negative 3 plus 1. Boom, boom, and there it is. That's the factorization. That's really as far as I'm going to get with those. Number 43. The length of a rectangle is 1 inch more than twice its width. The length is 1 inch more than twice its width. The value of the area is 5 more than the value of the perimeter. Okay. Find the width. Okay, so let's do this. The area being length times width is going to be width times length. I like to write it that way. Which is also 2w squared plus w. The perimeter is, let's write this kind of over here. The perimeter of a rectangle is 2 widths plus 2 lengths, or 2 widths plus, anytime you hear, if you hear anything, that's just my computer telling me my phone battery's charged, plus 2 lengths, here's length, 2w plus 1, which is 2w plus 4w plus 2, which is 6W plus 2. Okay, there's a way to express perimeter. There's a way to express area using those. The area, the value of the area is 5 more than the value of the perimeter. Find the width. So the area is 5 more than the perimeter. So 2W squared plus W equals 6W plus 2 and then plus 5. So let's combine like terms. 6W plus 7. Now let's set it equal to 0 by subtracting 6W, and we get 5W, and subtracting 7 like that. I think we factored this one as well before, only not in this kind of problem. It was set up this way. So I want to put the 7 here and the 1 here. I want my 5 negative, so I want a plus and a minus. This is 2 minus 7 is negative 5. W equals negative 1 won't work over here. Here, add 7, divide by 2. W equals 7 halves. They ask you to find the width, and that would be it. So the width equals 3.5 inches. Yeah, sorry, I was looking at the whole, I was looking at the units, the square inches, the inches, stuff like that, and it all's good. All right, it factored out, and that looks pretty good. That was a fun problem, actually. Number 44. Hey, you guys made a fun problem. I like that they were creative that way. All right, number 44. A rectangular swimming pool is bordered by a concrete... Oh, good. There are like other problems at the end. There aren't word problems. So this is kind of the end of the crux of them. A rectangular swimming pool is bordered by a concrete... I was going to say piano. Patio. The area of the surface of the pool is equal to the area of the patio. Okay. What is the width of the patio? So I'm going to redraw this. And here we have boom. How about boom? Got to get that boom. All right. So it looks like they say this is 24. And this is 16. So that area, 24 times 16... let's do 20 plus 4 times 20 minus 4. I should totally know this thing in my head. In fact, I do now. It's 256 plus 80, 336. I think it's 336. So let's see. 400 minus 16. Oh, no, it's not. It's not even close to that. It's 384. Okay. I don't know where I got the other answer from. Oh, I'm sorry. I was missing... What was I missing? I was missing something. You can just ignore it. Oh, I was doing 16 times 5, not 16 times 8. I'm good. Okay. Anyway, 384. That's not the answer. But this is 384. What else did they say? What is the width of the patio? Now, they say it's bordered by a concrete patio. The width is the same. Oh, I didn't read that. The width is the same on every side. So this width and this width and stuff are all the same. Okay, so that's another important part about this. Now, the area of the patio is that whole thing. So let me think about how they'd want us to best go about, because there's more than one way we can do this. The patios... The patio's whole length here, you take the 24 plus 2 W's here. This is 24 plus 2W. I should really say 2W plus 24, but that's okay. And then this whole height thing, for example, is 16 plus 2W. Again, I like to sight read these problems. Now, if I take that and I subtract the area of the pool, I will get the area of the patio, which is the same. But that's kind of a nice setup for this as well. If I take, I'm going to write this in blue. If I take the 2W plus 24, there must be other ways that I can do this that I'm not really considering. Oh, there are other ways I could do it, but that's okay. If I take 2W plus 24 times 2W plus 16, and I subtract out the area of the inside, then I get the area of the patio, which is also 384. Now, that part's important for this. I'm going to FOIL this thing out, and I get 4w squared plus 32w plus 48w, which is 80w. And then 24 times 16, which we found out, oh, that was 384. Yeah, see, this will get me right where I was. Minus 384 equals 384. Oh, goodness. Subtract these over, boom, those are gone. So another way we could have expressed these are, I got a 16 by w block here. So that's 16w. I got another 16 by w block here. I got a 24 by w block here, a 24 by w block here, and then a bunch of w squareds here. So what are you left with when you add all those together? You have 4 w squareds. You have 24 plus 24 plus 16, which is 80w. And that would equal 384, so I subtract it over. So perfect. So no matter what I do, one way or the other, I get to this stage equals 0. I'm going to go back to black, and I'm going to factor a 4 out of here. I imagine 3 to 4 can. So you factor a 4 out of here, I get w squared plus 20w minus 96. Minus 96 equals 0. Divide the 4 out. It's irrelevant to the rest of this problem here. So w squared, actually, yeah, I'll leave it there. It's a good old classic, just w case. What two numbers multiply to 96 and add to 20? Negative 96 and add to 20? You know what's funny is negative 12 minus 8 is negative 20, and times 8 is positive 96, but this is the other way around. It's a negative 96 product. So these numbers might actually be bigger because it has a difference of 20. So, okay, 24 and 4. So w plus 24, w minus 4. That's the first time I think we've seen something more than 12 that I'm thinking about. Oh, except for that 35 and 31. I guess not. But 24 times 4 is 96. So that works out. So w is negative 24 is not going to work for us, but w equals 4 will work out for us. They ask for the width. So the width is 4 feet. So that's the patio. They're talking about this thing. That's 4 feet across like that, which I hope is enough room for all the kidlings. Okay, 4 more problems, numbers 45 to 48. Yeah, my lecture took up about the first half hour of this, so hopefully these will be pretty okay. So 45 to 48, factor the polynomial. I have 4k squared plus 7jk minus 2j squared. I'll be honest, I don't like the appearance of this because it's not my favorite standard form. The fact that they have jk here instead of k, like I want the j first, go alphabetic, h-i-j-k. I want the j's first, excuse me. That's not a requirement, not at all. The answer in the back of a book might be different from this. I'll give you both versions of the answer. There's this version, but just keep in mind, whatever you put here, I got k terms here, and I got j terms here, or the other way around. Just keep that in mind. So here's one version. I'm going to do 4k and 1k. That's because 2k and 2k would leave me with an even number. Completely ignore j's if you can, guys. Think about this as plus 7k minus 2. Factors of 2 are 2 and 1, 1 positive, 1 negative. Oh, I can't put a 2 with that. 1 positive, 1 negative. Let's see if this works out like this. This would give me negative 8 plus 1, which is negative 7. I got to swap those signs out, so it'll be a minus and a plus. So this is one version of the answer. Distribute that out and see that you get that. Another version of the answer, if I wanted to be picky and say standard form and work it out, which I don't know if standard forms is required for factoring. It's required for this, was get the negative 2j squared first, alphabetically first, and then get 7jk as they put them alphabetically, and then plus 4k squared. Then I would have factored out the negative. You probably don't like this version as much. Minus 7jk minus 4k squared. And then in this case, this would have been a negative here. And then 2j and j, where the 4k squared would have to be from 4 and 1 in some way, right? And the 4 can't be here. It would have to be over here. So 4k and 1k would have to be here. I'd need negative and then plus. Negative 8 plus 1 is negative 7, and it would have been that. So it's the same thing in its own right. They're both two valid answers. I'm sure this is the answer they'd put on it. All right, let's hope they keep everything good. It looks like everything else is in standard form from here. You'll see number 47. I'm guessing 45 they would have put here because 47 is supposed to train you on the negatives. Now, if you're having trouble, once again, with these variable things, just ignore the other variable for a moment. Look, guys, I'm doing this. Look, guys, I'm doing this. There aren't any y's. I'll throw the y's in later. Let's just factor this first. Look, guys. Look, guys. All right. 6 can be 3 and 2 or 6 and 1. I'm not sure which, but the 4 is not going to be 2 and 2 because GCFs and because odd number. It's going to be 4 and 1. The 4 can't go here with that, so it'd have to be a 1 like that if it's 3 and 2. So let's try plus minus and see what we get. This will be negative 3 plus 8, which is 5, and that works. But remember, this was this and this. So what does that mean? Y and Y. Now, they don't generally put one Y, so I'll just put a Y just like that. And that's the answer. So if your perception requires you to not see those Y's to begin with, that's fine. If you want to write them first and then just come up with the numbers after, totally fine as well. So I'll try that in 47. Number 47, negative 6a squared plus 19ab minus 14b squared. I'm going to factor a negative out to begin with. And I get negative 19ab plus 14b squared. You know what? I don't think I mentioned this, and I don't know how much of my audience I still have. You do need to write this step in between first. You can't factor out a negative and go straight to here and look at these numbers because this needs to be negative and this needs to be positive, and you'll start making mistakes if you don't do that. Now, I'm not talking when you factor out negatives. I mean when you factor out any GCF, numbers or variables or anything. So anyway, so from here, you know, I'm actually almost more inclined to try the 6 first. Oh, there, that's a 14. That might be fine. I'll try the 3 and 2. I was going to say just because the 19 is so big. But with 14, I got to try 7. I got to try 7 probably with the 3, especially because 2 can't go with 2. So I'm going to try that. Negative 21 plus 4. Oh, that doesn't work. Negative 21 plus 4 isn't negative 19. So that actually does not work. Does 14 and 1 work with these numbers? I don't think so. If it does, I got to try the 14 here and the 1 here. Negative 3 plus 28. That doesn't work. So it's not 3 and 2. It's not 3 and 2. Let's try 6 and 1. By the way, notice I haven't put the b's in yet. 6 and 1. Now let's try. I can't put 2 or 3 here, so it'll have to be 1 and excuse me. I can do 7. I can put 7 here. I was thinking of 14. So let's try negative 12 plus... Oh, this is a plus 14b. Oh. All right. Well, you know what? This will work. Negative 12 minus 7 is negative 19. I'm sorry. I was probably looking up here, just like I said I shouldn't. So that'll factor into that. Oh, b's. That'll factor into that like that there. All right. As I spoke out loud, I got a bit of my thought process. And lastly, number 48. Hey, we get to have a GCF of a variable this time, alongside maybe other numbers. Let's see. 48. We have 18m cubed plus 39m squared n minus 15m n squared. If you notice, all of these have m's. Furthermore, if you notice this is not a quadratic, you got to factor an m out of that thing. 3 can also factor out of these. And you're left with 6m squared plus 13mn. Remember, an m factored out. Minus 5n squared. Remember that n factored out there as well. So m's and n's. The 3m still sticks out here. And do I dare try 6 again? I'm going to try 3 this time. 3 and 2. 5 is 5 and 1 of some sort. 3 times 5 would get me to 15. That's pretty good. I think this will work out. I need to get to 13, so 15 minus 2 would give me that. 15 minus 2. And I need n's on these guys here. So 1n becomes n, and 5n becomes yes. Just like that. All right, and that is the answer to that set final factorization. Okay, guys. With that said, that ought to do it for this one. This is Mr. Robinson. Thank you so much for watching. Check out the playlist if you want to see other videos of the sort. Next will come section 2.7 whenever it comes in, and then 2.8, and then whatever chapter review and chapter test and cumulative review. But that was a biggie. I hope that you followed along in a way that it made sense to you and you could practice it more and more and have some fun with it, because when you get it right and you know your number sense, it goes really, really fast. None of these were unfactorable. Those are the frustrating ones because you're not convinced whether you're doing it right or wrong. That'll do it for this one, guys. This is Mr. Robinson. Thank you so much for watching, and take care. I will see you in the next one.